Well, ladies and gentlemen, turns out there is a third way to solve a system of equations. Remember, solving a system of equations is finding the one point that makes both equations true, or in other words, the one point where the two lines would cross on a graph. So, the third method is called the elimination method. And this method at times is the easiest one because the equations are set up to do it. So I'm going to walk through the steps first and then an example. So I need you to put this into your notes, the steps for the elimination method. They will make sense as we go through the example. So step 1, the first step of this is to make the two equations look the same. And now when I say look the same, what that means is to get the x and y on one side. So get the x and y terms on one side of the equal sign, and the numbers on the other side. Now, technically, you don't have to have them look this way, but it's kind of a nice standard to get into. When you get that like that, write the two equations above one another. So write them above one another so they line up. Now, step 2. Step 2, we won't have to deal with in the first example that I do. We'll practice a few before we have to do this one, but I need you to put it in here so that as we get to the more complex ones, the progression is correct. So make one of the numbers in front of either x or y the same. And you make them the same in both equations. Now, or either the same or they can both be opposites of one another. You'll see what that looks like. And we can do this. You do this by multiplying. The equations. And sometimes it's one equation, sometimes we have to actually multiply both equations. When you have that done, step 3 is to add or subtract. And it depends if you add or subtract, depending on whether you made the numbers the same or you made them opposites. So you add or subtract the two equations together. So that either the x or the y disappear. One of those two variables will disappear. After that, you solve for the remaining variable. Plug that solution into either equation, and solve for the other variable. At that point, you have your answer. All that's left is to check it. I'm going to give you a second. You're going to want to pause the video at this point and copy these 6 steps into your notes so you have them to refer to as you're doing problems. So pause the video and copy these into your notes now. Assuming you have these steps into your notes, we are now ready to solve using the elimination method. So let's solve the following. If we have the equation 3x plus 2y equals 7, and the equation 4y equals 5 plus 3x. If these are my two equations, this is my system of equations, I want to find the solution, or in other words, find the point where these two lines intersect, the point that works and makes both equations true. First, it says make the equations look the same. Get x and y together on one side, the number on the other. Here, x and y are together on one side of the equal sign, the numbers on the other. This one's good to go. This equation has y on one side, but the x is on the other. I need to move them to the same. I'm going to do that by subtracting 3x from both sides. That will leave me negative 3x plus 4y equals 5. Notice I wrote the x first, the y second, because this one has the x first and the y second. Now, I want to put these two equations above one another. So I'm going to take this one and I'm going to write it right below this one. Step 2. That's step 1, by the way. Step 2 says make one of the numbers in front the same or opposites. So in front of the y I have a 2 here, a 4 here. They're not the same. But in front of the x I have a 3 here and a negative 3 here. Those two numbers are opposites of each other, meaning I am done with step 2 in this problem. I move to step 3. Step 3 says add or subtract these two equations together so that one of them disappears, and it's going to be the one that has the same or opposite number that disappears. So I have a 3 in front of the x, a negative 3 in front of that x. I'm going to either add or subtract them, and I want the answer to be 0. Should I add or subtract 3 and negative 3 to make it 0? Well, 3 plus negative 3 is 0, where 3 minus negative 3 would be a 6. So I want to actually add them together. I'm going to add this time. 3x plus negative 3x is 0. 2y plus 4y is 6y. The equal sign comes right along. The 7 plus the 5 is 12. I have now, get that y by itself, divide both sides by 6. I'm solving for the remaining variable. That is step 4. I get y equals 2. There's half of my answer already. The y is 2. How do I get the next? It says step 5, plug that into one of the other equations. I have lots to choose from now. I can plug it into this equation, or into this equation. It does not matter. Oh, eeny, meeny, miny, mo. I'm going to go with this one. So for the y is 2 equals 5 plus 3x. Going to get x by itself. That's 8. I'm going to subtract 5 from both sides. So 3 equals 3x. Going to divide by 3. And I get x equals 1. All that's left is to check. So checking in the first equation, 3 times the x was 1, plus 2 times the y was 2. Do I get 7? Well, 3 plus 4 is 7. And now I'm going to plug it into the original one they gave me. So 4 times the y was 2. 5 plus 3 times the x is 1. Are they equal? That's 8. That's 5 plus 3, which is 8. I did indeed find the one and only 1 point that makes both equations true.